Hey YouTube, O'Dolly here. Just thought I would update you on my rocket stove retort. Had quite a lot of interest into the design and some updates that I've been working on. So I'd just like to go over a brief overview. In the 55-gallon drum, I have placed this rocket stove. It's made out of 6-inch steel pipe. It's approximately a 1/4 inch thick. Actually chunks of a hydraulic cylinder that I welded together. And as you can see here, I have this 1-inch threaded pipe that I have connected to a cup link, which is welded into the rocket stove. So here's the semi-completed retort. As you can see here, it's inside this wooden box. It's got a pallet underneath. You can see I have these little metal feet that I welded up to help hold the 55-gallon drum up off of the wooden surface, just because I know it's going to get really hot. And underneath that, I've placed 3 or 4 paver bricks, one directly underneath of the rocket stove, just to help keep the weight off of that 55-gallon drum, because I know just how thin that steel is on that drum that it would cause some warping. So here's a photo of the wool rock insulation being installed. The insulation helps, to trap the heat within the barrel. This insulation is non-flammable, but it does have a problem, as it will break down over time just from the many heating cycles. Its original use is for inside houses. This is definitely not the best stuff to use in this situation, but for cost purposes, it's what worked out for us. What probably would be best is some sort of ceramic wool, but that stuff was way out of the price range for this project. So after adding the wool rock directly around the 55-gallon drum, I filled the extra voids with extra pink insulation that I had laying around. So after running the retort a few times, we came across a couple design flaws. The 55-gallon drum would get so hot that we were afraid that the wood surrounding it would catch on fire. There were times we had to douse the sides with water just to keep things cool. So what we did is we went around the edges and we drilled a number of air vent holes to let hot air pass out around the wooden box we built around it. I also went through and added some 1/2-inch cement board around the outside. Cement board definitely helps to keep the heat contained. So after installing this cement board, we put back all the wool rock and pink insulation. One other design flaw was the rocket stove section was not making a complete seal against the 55-gallon drum, so there would always be some gas leakage, and that gas was leaking inside the wooden box, and we were worried that that was going to heat things up too much. So what we did was add a section of 8-inch pipe, chimney pipe, that came through the outer section of the wooden box and fit up against the 55-gallon drum. Any gases that would leak from the 6-inch steel retort would be drawn out of the box and it's just escape into the air outside. So here's the outside of the retort. You can see the cement board. You can see the insulation in there has started to crumble up. With every running of the retort, the insulation is just breaking down. So you can see down here in the bottom of the retort, you can see the 1-inch stock that I have down, well, it's 1-inch angle I have down there to help hold the retort up off the bottom. And there you can see the 1-inch pipe. The 1-inch pipe comes right up to the maybe an inch or two below the lip of the 55-gallon drums, where we start the fire and keep it going. I have noticed quite a bit of scaling off of the rocket stove just because of the heating cycles. You know, it's not going to last forever, but I've run the retort probably maybe 15 times so far. So yeah, the insulation has really broken down. You can see it's just all little bits now. And there you can see the cement board. Up on top you can see it's singed a little bit, but you know, down where it's protected with the insulation, it's not a factor. I've taken my infrared thermometer and tested the sides while the rocket stove's running, and where we get up into the, I think it was 100 and 150, 160 degree range. The top of the rocket stove will get, I think it was like 500, close to 600 degrees at times. The actual rocket stove section, I've had it go off the meter, so the meters goes up to 1,000 degrees. So here's what I use for wood inside of the retort. This is all scrap maple from a local tabletop company. It's all been kiln dried, so it's really, really dry. So here I've got the chimney that goes on top of the retort, and there's the hole that I feed wood into. Here's the lid. This is the lid to the 55-gallon drum. You see I have a little exhaust vent there that is welded to a coupler, and that is attached to the 55-gallon drum on the opposite side with a coupler. Here is the band that cinches down the lid on the 55-gallon drum. Our normal procedure is to pound it down with a rubber mallet just so we get a really nice tight seal, and then cinch it down. Piece of metal scrap I put over the exhaust vent just in case any excess pressure builds up in there, it has a release. And so here I am putting the chimney on top of the retort. This coupler's seen better days. So here's the rocket stove filled up with wood. So it'll fit like 45 gallons of wood scraps. So in between the retort and the lid, I place either drywall compound or high temp caulk. So here I am, I've started a fire in the retort. I start a small fire in the bottom, and I usually feed the stove from the top. So the wood will fall right down into that elbow and it'll burn there. I also put a little bit of sand over top of that joint just to help keep that airtight. So you can see here and here now the retort is going. So what's happening here is the wood is gasifying. It's off gassing, and since there's no way for the gases to escape the 55-gallon drum, the fumes are coming down through the 1-inch pipe. They are hitting it's hitting the fire at the bottom of the rocket stove and it's igniting. So once the ignition of the gases begins, the stove will run by itself for approximately 3 or 4 hours with some attendance. Occasionally the flame will go out. It all depends on what is in that gas and how flammable it is, and if there's a wind gust. I've thought about making up some sort of flame that's always lit in there to keep a live flame on that on those gases. But another problem I have is you can see here that charcoal and ashes will build up in the rocket stove section, and it chokes the oxygen out. So I've thought about how can I add in like just a secondary air, just to bring in air to the ignition area around that 1-inch pipe. So here we are, it's the next day, and we're going to unload the charcoal. Just disassembling everything here. The lid is usually a little tight, but comes off fairly easily. Usually that drywall compound or the caulk is usually burned off. So there you go. As you can see, the total volume of the wood has decreased by a little bit less than half. So we go to 40, 50 gallons of wood scraps, and it condenses down when it's all done to approximately 35 gallons. So with this design, it usually takes us 3 runs to make 100 pounds of charcoal. So one of the pains of this design, really the only pain that I see, is unloading this thing. So it's all got to be done by hand. I've thought about creating some sort of a basket out of hardware cloth that would fit inside this 55-gallon drum, and then from there you could hoist it out with by hand or with a tractor or something. We'll see if I can come up with some easier way to unload. The only problem with a basket would be, you're losing some volume just because of the odd shape that that basket would have to be inside of that drum. This process usually takes 10 to 15 minutes. And it's good to wear a pair of gloves because charcoal, especially the stuff that I have, is kind of sharp at times. So when we get down to the bottom, it's quite a reach to try to get down there. So I use this bent ash shovel and a stick to push the charcoal around. There you can see some more of that scaling on the rocket stove section of the retort there. So the whole purpose of this project was to create biochar and charcoal for forging. I haven't found a really easy way to break down the charcoal into a manageable size quickly. The way I do it now is I throw it into this electric cement mixer and add in compost tea and a bunch of rocks. So as you can see here, the rocks are tumbling and mashing up the charcoal into tiny little bits. And so if I leave it in there, I can probably do 5 or 6 gallons at a time of large chunks of charcoal, and that'll break down, over 20 minutes into a pasty, very wet, pasty substance. And from there, I take it and apply it to my raised beds or to my garden and mix it in well with the soil. For the other use, you can see here we are smelting seal. My friend Tim is using it to melt down iron-rich sand that he has collected in. So a couple final thoughts. This year I'm planning to get rid of the wooden box that surrounds the retort. I'm thinking to surround it with some recycled sheet metal that I found. Either reuse the insulation that I've got, or possibly I wanted to test out just filling it with sand to see if that would still work. I'm trying to think of ways to make this project cheaper. I've got a second 55-gallon drum that I'm looking to create 2 of these so I can do more batches at once. The other thing I'm thinking of changing is possibly adding in a secondary air input down to where the 1-inch exhaust vent comes in. Hopefully this will help maintain the flame in the rocket stove. Well, thanks for watching. If you have any comments, please leave them below. Like and subscribe if you want to see more of these projects. Thanks.